presentation focuses on intermediate prompt engineering techniques. The goal is to understand how to guide AI models to produce more logical, structured, and professional responses. While basic prompts simply ask questions, intermediate prompts guide how the model reasons and organizes its answer. By controlling reasoning and structure, we can achieve better accuracy and clearer explanations for complex tasks. Large language models generate responses based on patterns learned during training. If a prompt encourages explicit reasoning, the model simulates a logical thinking process instead of jumping directly to an answer. This approach significantly improves results for tasks that require deeper thinking. Examples include mathematical calculations that require multiple steps, logical puzzles involving deductions, decision-making tasks where options must be evaluated, programming tasks such as debugging or writing code logic, and analytical explanations that require breaking down complex ideas. Without reasoning guidance, AI responses may suffer from several common problems. First, incorrect answers. The model predicts the most likely response without analyzing the problem carefully. Second, hallucinated information. The model may generate fabricated facts when deeper reasoning is required. Third, shallow explanations. Responses may be brief and lack detailed educational value. To solve this, prompts should encourage a structured reasoning process. This process includes analyzing the problem, dividing the task into steps, evaluating intermediate results, and producing a logical final conclusion. Let's look at a simple example. A basic prompt asks, "What is 25 times 16? The response might be 400, which is correct but does not show how the answer was calculated. Now consider a reasoning prompt. Solve 25 times 16 step by step and explain the calculation process." The model then breaks the problem into steps. First, it breaks the expression into parts. 25 times 16 equals 25 times 10 plus 6. Second, it multiplies separately. 25 times 10 equals 250, and 25 times 6 equals 150. Third, it adds the results. 250 plus 150 equals 400. Finally, it produces the answer. This reasoning chain makes the solution transparent, verifiable, and educational. Structured prompts organize instructions clearly. Without structure, AI responses can become disorganized and inconsistent. A structured prompt typically includes several components. Role defines the perspective the AI should adopt. Task describes what the AI must accomplish. Context provides background information about the audience or situation. Format specifies how the response should be organized. Constraints define limits such as word count or language style. Using these components ensures that the AI clearly understands how to respond. Let's look at an example of a structured prompt. The role might be, you are a mathematics teacher. The task could be, explain how to calculate the area of a triangle. The context specifies the audience, such as 8th grade students. The format defines the structure of the answer. The response may include 4 parts: definition, formula, example, and a final summary. With this structure, the explanation becomes organized and easy to follow. For example, the formula is area equals 1/2 multiplied by base multiplied by height. An example calculation may show a base of 10 centimeters and height of 6 centimeters, producing an area of 30 square centimeters. This structure produces clear and predictable responses. Intermediate prompting provides several important benefits. First, improved accuracy. Step-by-step reasoning reduces mistakes. Second, clearer explanations. Structured responses follow a logical flow instead of random text. Third, reduced hallucinations. Providing context and instructions limits fabricated information. Fourth, consistent output. Predictable formats help with documentation, data extraction, and automation. Finally, easier evaluation. Visible reasoning steps allow solutions to be verified easily. Reasoning and structured prompting are especially useful for tasks that require logical thinking. For example, mathematical problems such as solving equations or explaining formulas. Coding tasks such as debugging programs or explaining algorithms. Data analysis tasks like interpreting datasets or generating reports. Research and education tasks such as summarizing research papers or explaining scientific concepts. In these situations, reasoning and structure significantly improve response quality. There are 3 key ideas to remember. First, control reasoning. Guide how the AI thinks by requiring step-by-step analysis instead of direct answers. Second, define structure. Specify how responses should be organized using clear format instructions. Third, improve quality. Combining reasoning and structure greatly improves accuracy, clarity, and usefulness. The key concept is that prompt engineering is not just about asking better questions. It is about designing prompts that control how the model reasons and structures its response. To continue improving your prompt engineering skills, follow these steps. Practice regularly by applying these techniques to real tasks. Experiment thoughtfully by testing different reasoning frameworks and structures. Share best practices with others by documenting successful prompt patterns. Mastering intermediate prompt engineering enables professional-grade AI interactions for technical, analytical, and educational applications.